Good morning, ladies and gentlemen. Today is Tuesday, April 21st, and we are going to continue our lesson on theoretical probability. And I had this slide available to you yesterday. Let's just review a little bit what theoretical probability is. Theoretical probability is what should happen. If it was a perfect world, what should occur when you roll the dice, spin a spinner, or flip a coin? So it's what should happen. Everything would come out fair. So if I bring in this spinner here, and you'll notice that in this spinner here, I have 8 different sections. The probability of landing on the red would be 1 out of 8 because there's only one. The probability of landing on the orange would be 1 out of 8 because there's only one. So each part here is equally likely. And so if I were to ask what's the probability of landing on blue, our answer would be 1 out of 8. If I asked what's the probability of landing on an even number, well, 2, 4, 6, and 8, there's 4 out of 8, which would equal 1/2. Let me bring in this die. This is a 12-sided die. So you'll notice each side is a pentagon, and every side is equally likely to land on. If I were to roll this die, I get an equally likely chance of landing on the 10 as I do landing on a 3. So if I want to know what the probability of landing on a 3 is, that answer is going to be 1 out of 12. If I want to know what's the probability of landing on a 2, that also is 1 out of 12. So it's what should happen. Everything is equally likely in these events. Okay? So let's take a look at some more examples, kind of extending on what we did yesterday. I just talked about figuring out what our theoretical probability is. So I'm going to skip over this slide, and let's go ahead and look at this spinner that I have. So my action is one spin of the spinner, and I need to find the probability of the spinner that stops on each type of sector. So when I look at this image, my first one is asking what is the probability of landing on red. So we have 1, 2, 3 red out of a total of 8 sectors. So the probability of landing on a red is 3/8. If we move down here, we have red with an odd number. So again, I have 3 reds, but when I look at those 3 reds, only one of them is odd. So that is 1 out of, and again, we have 8 sectors. Green, take a look at our spinner. How many greens do we see? There are 2 of them. So that's going to be 2 out of 8 sectors. And remember to reduce your fractions. On your assignment today, your fractions do have to be simplified. So 1/4. A number that is less than 10. Well, if we look at this spinner, every single number is less than 10. So that's 8 out of 8, which gives us a probability of 1. Landing on a yellow, there aren't any yellows in this, so that's 0 out of 8, which is going to be 0. It's impossible. We cannot land on a yellow. And then finally, landing on a blue with an odd number. So if we look at our blues, I see 1, 2, 3 of them. And when I look to see which ones are odd, I have 2 of them that are odd. So again, that's going to be 2 out of 8. And we're going to simplify that fraction again to 1/4. Okay. So now we are on page 418 in your math book. And I'm going to tell you that your question in your book is different than what I have on my slide here. And I'd like you to use my question instead of what you have in your book. So here I have a bag of buttons, and we want to go ahead and find the probability of choosing a certain type of button. And so this is the first question that's different from your book to what I have on my slide. What is the probability of choosing a blue button? So take a look at my image on the video, count up your blue, and then make sure you know what your total number of buttons are in that bag and write your probability. There are 6 blue buttons, and if we count all the buttons, we know we have 6 blue, 7, 8, 9, 10, 11, 12. So that's 6/12, which is the same as 1/2. Our second question wants to know what's the probability of choosing a 2-hole button. So take a look at your book, look really close, and you are looking to see which buttons only have 2 holes in it. And your book is actually better than my video. And so you should have counted that you have 4 buttons that have 2 holes in it out of a total of 12. And remember, we always want to simplify that answer. And so that is going to be 1/3. So that is reviewing with you what we did yesterday, theoretical probability. Now we are going to, I forgot about, we have another question on page 418. Let's answer this one first. The spinner is divided into 2 unequal sectors. The outcomes for red and blue are not equally likely. What could we do so that we could use theoretical probability to find the probability of spinning a red? So they've already told us that 1/4 of the spinner is blue and 3/4 of the spinner is red. So what could we physically do to this circle so that we could find the theoretical probability of landing on a red? And the answer to that is to take your circle and cut it into quarters. Now that we've cut the circle into quarters, we can now say that the theoretical probability of spinning a red on our spinner is 3/4. Okay? So now what we'll do is let's talk about and compare the difference between experimental and theoretical probability. So we've been talking about theoretical probability yesterday and at the beginning of this lesson. And so theoretical is what should happen. So if it was a perfect world, will the baby be a boy or a girl? So our sample space is a boy or a girl. So if the outcomes boy and girl are equally likely, then our probability theoretically is 1/2 that all the babies born will be a boy or all the babies in the world will be a girl. Well, that's not necessarily the case. When we think of experimental probability, experimental is what does happen. What is the actual occurrence? And when we have experimental probability, more than likely, we always have some type of a table of data that help us answer our question. So, will the baby be a boy or a girl? Well, if we look at the data collected in 1 year and we find the probability of it being a boy, you'll find that that percentage is not 50%, but actually 51%. And there's a typo on here. There shouldn't be a percent sign. So this is what really happens. An experiment is what happens, what actually occurred when you kick a ball, spin the spinner, flip a coin. Theoretical is what you think will happen before you do any of the experiment. So let's take a look at an example. And what we will need to do here is we are going to identify if the examples given are experimental or if they are theoretical. And so question A says a soccer player took 12 shots on goal and scored once. So the probability that a soccer player scores on a shot is 1 out of 12. So we have to think, this 1 out of 12, is that what happened when they really kicked the soccer ball? Or is that what should have happened before they kicked the ball? And the correct answer is experimental. It tells us in the problem that they took 12 shots and they scored once. In theory, what should happen when a soccer player kicks a ball? They either make it or they don't. So that is theoretical. Question B, you roll a standard number cube 50 times and you get 8 threes. So here it tells us the probability is equal to 8 over 50. Is this fraction 8 over 50 based on an experiment, something that somebody actually did? Or is it based on theory, what should happen? And that is based on experimental probability. It tells us that they rolled the dice 50 times and they got the number 3 8 times. Question C, it says you choose one tulip at random from the vase. We're finding what is the probability that it is going to be red. Okay, so here's our vase. Here's our tulips. We have some red, we have some yellow. Is this probability of choosing a red tulip experimental? Did we perform an experiment? Did we take tulips out of the vase and count how many reds we got? Or is this theoretical? In theory, what should happen? And the correct answer is this is theoretical. And now we'll go ahead and we'll answer the question at the top of page 419. Which probabilities are experimental? So we want to know of the 3 that I have here, which ones are experimental, where they actually performed an experiment, collected data to get their results. Question number 1 says an eye doctor examines 10 people and finds that 4 of them are colorblind. So the probability of being colorblind is 4 out of 10. Number 2 says a teacher chooses one student at random from a class of 13 boys and 12 girls. The probability of being a boy is 13 out of 25. And finally, question number 3, it says you check 6 boxes of cereal and find that 1 box has a prize in the bottom. And the probability of that occurring is 1 out of 6. So again, of the 3 that are listed here, which are experimental? Which ones did they perform an experiment, collected data to get their fraction answer? And the correct answers you should have circled are problem number 1 and problem number 3. So ladies and gentlemen, for tonight, you are going to complete lesson 16.4 in your digits program. And tomorrow we will practice identifying again the difference between experimental and theoretical probability.